I would like to welcome you to our presentation of the Applause use case 2. This is about a thermal infrared image sensor. This use case is led by the company Integrated Detector Electronics AS, in short, IDEAS. And I would like to hand over to my colleague Nishant, who will now present the slide on the technology that we are developing in this use case.
Thank you, Dirk. Every object emits electromagnetic radiation with a broad spectrum of wavelengths related to their temperature and emissivity. Unfortunately, our eyes are only sensitive up to 700 nanometer wavelength, which is a great limitation and prohibits many applications. Infrared sensors, on the other hand, are sensitive beyond 700 nanometer, which enables one to measure surface temperature remotely and makes it even possible to analyze the gas, air, and surface chemistry. Thermal IR sensors are used for night vision, see-through smoke, fog, and dust. Overall, the infrared imaging enables many technologies and applications, for example, in thermography, surveillance, and automotive, which are important for many industries and services. In the center, you can see the example of a thermal image of a human. This is an image which is taken by a low-cost IR camera, which is available in the market. You can see it's a really bad quality image. In the center, you see a human face, which is warm. That's why it's colored as red. And the other parts are colder, which are color-coded with green and blue. Here you really notice a poor image quality, poor resolution, and poor frame rate. In this project, our goal is to enable low-cost but high-performance thermal image sensors for the application in automotive, safety, surveillance, and security. Here, we are working towards a goal to establish the manufacturing capability of thermal image sensor products. This includes foremost the development of the most important processes, which is wafer level bonding, advanced packaging, but also the improvements in MEMS microbolometer technology and CMOS readout integrated circuits. In the Applause user case 2, we aim at developing a thermal image sensor, which includes the room temperature operated microbolometer arrays, readout integrated circuits, hermetic wafer level packaging, advanced packaging, and finally demonstration of the fabrication process, but also a demonstrator infrathermal image sensor prototype.
Use case number 2 has the following partners and their tasks. This is IDEAS coordinating the use case and also designing the ROIC. University Southeast Norway working on wafer bonding. Fraunhofer IZM working as well on wafer bonding and wafer level packaging. Fraunhofer ENAS working on reliability testing and simulations of the wafer bond and the package. And Fraunhofer IMS working on the bolometers. PACTEC working on packaging. DISCO working on wafer dicing. CSAM working on wafer bonding. Root Microtech working on the testing and reliability testing of the entire device. EDI working on the embedded software and the demonstrator. EDG on instrumentation for wafer bonding. KLA also on wafer bonding, instrumentation, and optical instrumentation. Würth Electronic on the circuit board, design and manufacture, and the wire bonding. BESI Austria works on die attach. BESI Netherlands works on the advanced packaging with the molding, and Aalto University works on wafer bonding. Nishant could summarize our outlook for the next phase.
Yes. User case to outlook for the next phase. So we continue the process R&D related to wafer bonding and advanced packaging, and eventually we are going to end up demonstrating wafer bonding and advanced packaging, which will lead to the functional thermal camera demonstrator.
If you find our project interesting and you have any questions or would even wish to create business with us, please don't hesitate to get in touch with my colleague nishant.malik@ideas.no or myself dirk.meier@ideas.no.